Hello, everyone. So with automation, as we know and we've heard throughout the morning, you need a solid data management strategy. We heard it time and time and again, especially with the congressmen earlier. These guys here have been working on some pretty cool initiatives in that regard, and I'm looking forward to hearing more about them. So you should too. So let me start by opening it up to the panel. Any of you can jump right in with this first question. What is the importance for government agencies to develop a solid data management strategy before performing automation functions? Kris, let's start with you.
Sure. All right. Thanks for having me. It's a great event. Yeah, in terms of a data management strategy, I'll talk very briefly about top-down and bottom-up. So from a top-down perspective, as Chief Data Officer, I have to flow throughout the organization. I have to be able to coalesce leadership around common priorities, common problems, common theories, and at the same time be able to translate those back down to our data scientists, data practitioners, who are engaging with the data to build the capabilities, the analysis, prove the theories, and then be able to help translate those up through the chain. And if you don't have an enterprise data management strategy where you're trying to build and connect the various data capabilities across the agency to be accessed by those data practitioners, it's very challenging to build the capabilities to prove those results. Automation plays a role there in doing that, but it's not necessarily an essential thing that you have to have in order to get started. What you really need to get started is the upper level engagement around understanding what the needs, challenges, and priorities are, and an accessible route to get to those data practitioners to help proving how you solve it. As you build momentum and you prove value, then you can start to think more about automation and the technology aspects around it.
Okay, what do you think?
No, that's a great point. First of all, thanks GovernmentCIO for having us here, and thank all of you guys for attending. I think collaboration is key to innovation and adoption as well. So I thank you guys for coming here this morning. I think I'll make it simple. I think the biggest hurdle is getting away from paper. I think you have to make sense of the data before you have a data strategy, and you can't analyze paper. We have too many paper in the federal government. I think just trying to digitize the data, that would be the first step. That would be the biggest hurdle. If you could achieve that, then you could go on to the next stage of analyzing the data, mapping the data, looking at some, things that might be double work or duplicate, something that you are overlapping. There's a lot of overlaps in the government. I think once you figure out the data, then you could free to do RPA or AI. I think for us in HSS, we use machine learning. Once we digitize the data, is to categorize or cluster the data or classify the data, because data comes in different formats, unstructured, structure, emails in some cases, Word, photos in some cases. I don't know. I mean, there's so many unstructured data. You have to make sense of the data, and we use machine learning to cluster the data to make sense of it. And then you are able to free yourself to start doing data mapping. Not only that, but you can condense some of the processes, but also having insights on performance measures, strategic analysis, because data has a lot of insight. If you can make data smart, you could do a lot of things with data. I think data is the key. But the biggest hurdle is getting away from paper.
And Kirk, your product fits in with all this, so can you talk more about that?
Yeah, so I'd like to attack it from a technology perspective. And if you look at any successful AI project, it's highly contingent on having access to massive amounts of data and information. The interesting aspect of that, however, is that information can be housed in multiple forms. It can be structured, unstructured, and even object technology now, right? And so you have these three dissimilar technologies all needing to come together in order to generate a successful return on your investment for an AI project. What we found is that customers are trying to attempt to solve that consolidation problem through the creation of data lakes or potentially data oceans. What we find there is when you combine all that information, the information content in those data lakes now is governed through multiple restrictions and multiple compliance regulations, whether it be PCI data, healthcare data, HIPAA data, maybe even classified information. And so it becomes a challenge from a metadata perspective in terms of access control and how do you manage that data in those lakes. And so what we're starting to see now is an emergence of a technology called a polystore. Polystore lets you store that information in its native format, but then aggregate all that metadata at a point in this, think of it as an abstraction layer that's at the top of it, the polystore layer, which will then give you an ability to come in, access that information with the appropriate granular access controls on that data in its native format, and then still present all that information back up to its AI engine so that you can start to do training and then real-time inferencing.
And David, I know you are more alongside the AI route, so where does the strategy fit in on those lines?
Right, it's foundational, right, to have quality, clean, uniform data that you can leverage that's in large quantity, right? So if you don't have those in place, you're not going to be able to trust the outcomes that you have with the AI. So in many ways, it's one of those pieces that if you have that in place, you can help leverage the exciting potential that AI has.
Great. So help us understand some of the hurdles that go into making sense of data. Oki touched on, the paper-based nuances that come with trying to do that. What are some other ones, Kris?
And I talked about this a little bit. The volume of data and the accessibility of it is growing, right? And we have a lot of legacy environments that exist out there, and historically it's been difficult to get these environments to communicate with one another. Technology is advancing to make that easier, even without having to modernize an entire application or platform. So the connectivity of data or the accessibility of it is becoming easier. The challenging part is when you start having this large volumes of data coming in from all directions, is really trying to narrow it down to the most valuable components of that data and how they align to challenges or problems. I think the part I discourage when people come to me and say, how can I get a bunch of data to do a machine learning pilot? And my response back to them is, tell me the problem you're trying to solve or the theory that you have, and then let's go do some data discovery to see what has it. Don't start with data, start with the problem or the challenge, because otherwise you're going to spin your wheels trying to accumulate large volumes or get access to large volumes of data with maybe no use case.
Oki, you were kind of involved in that as well as far as making a business case. So can you go into that a little bit?
Yeah, I mean, you're right. It starts with the business, not start with the technology. I always say, there's no such thing as IT project, as business project with IT components. It's always started with the business. It doesn't, whatever it leads to AI or RPA or blockchain, doesn't really matter. I mean, it's how are you solving the business issues. Adoption or innovation is not the emerging tech, it's the processes. I think that people think that it's AI's plug and play, but people don't realize that if you want to do AI work, 80% of it will be normalizing the data, fixing the data, cleaning the data before you could, start doing AI. You have to start, you crawl, walk, run steps. You have to start from looking at the data. Most of the work is cleaning the data. But I think the biggest hurdle, is culture within the federal government. The technology is not the challenge, is the culture. I think in order to fix an issue, or fix a problem, you have to admit that you have a problem before you can fix it. So I think we have to come to our senses and say, hey, we have issues with pushing paper around. There's a lot of data, there's a lot of insight that you could gain from data, but you can't do it with just pushing paper around. You have to digitize the data. That's the first thing you need to do before you start normalizing, analyzing, using predictive analysis. It's just, we need to get away from paper and we need to embrace change. You have to evolve, otherwise you become obsolete. I think that's the key.
I guess it's me. I'm going in cereal. So I'll try and summarize what the two prior speakers had really tried to crystallize in a simple statement. Accessing bad data will render every AI tool useless. right? And you have to spend that time and effort in creating normalized data sets so that you have good quantization levels. And if it's scientific data, for instance, make sure your ranges go from 1 to 1,000 or 1 to 1,000,000. Changing that one step from 1 to 1,000 to 1 to 1,000,000 may increase the time to actually train a machine learning network to the point where you don't reach convergence, and so you spend a lot of wasted time by going through this quantization, ultimately to find out that you can't converge on your network, right? And so there's a lot of iterative process that's involved as you work through these technologies. That's where I think there's some interesting technologies that actually help at the storage layer or at the data layer, right? So something as simple as copy data management can be extremely useful for an analyst or an AI practitioner. Think of the concept of when we go through that normalization, we go from 1 to 1,000 to 1 to 1,000,000. The idea is when I run that 1 to 1,000,000 data set and it didn't converge as expected, I want to be able to revert back to that data set in seconds, right? And conceptually, if it's a petabyte data set, you don't want to create 2 petabytes of information just to find out that requantization did not work. That's where interesting storage technologies come into play, give you the ability to revert back to that previously good data set and go off and run. And then as you start to move into real-time inferencing, the idea of cloning that information with storage efficiency or space efficiency also comes into play. And so we can conceptually take that core data set, clone that multiple times as writable copies, hand that off to the different models, and then run simultaneously. Gives you the ability to come to convergence faster and then ultimately get to inferencing in real time. And so there are some clever technologies that can be employed to help with this data management problem.
And David, VA is making strides in AI, so maybe you can touch on that point.
Sure. Yeah. Well, actually, I was just reflecting on kind of the promise or the growth that we have had, right? Because 5-6 years ago, I'm manually working with the medical record data of millions of veterans and having to clean that, manually. And now we've become more sophisticated. The field has matured so that we're able to kind of address these things in, a better way. And what's very exciting is that now the VA is poised to leverage AI in a way that's I think unique, right? Because of our data and our mission and that the delivery of healthcare. And so with the potentials for AI, we're actually working and collaborating with folks. And one of the things that we are doing in this is actually key about this data sharing. You're talking about this where kind of an iterative sharing of data and working together can help improve the quality of it. And one of the main things that we're doing right now in AI is a AI tech sprint. So this is a time-limited engagement on a specific use case. So we just did clinical trial matching for veterans, and this brought in academic and industry partners, and we provided data safely to these partners. And there's a back and forth as far as like understanding the data, understanding what the problems are, and with the data, and then sharing that with stakeholders that are a part of the VA, so veterans, stakeholders, leadership, VA leadership, giving feedback on the tools that this data is being used for. And so we're basically getting everyone together and working collaboratively to help basically leverage our AI tools. Yeah.
So each of your agencies have developed programs for fostering innovation in data management. Can you go into, in more specifics, what those efforts have been? What programs have you been involved in and are maybe looking forward to in the future? Kris?
Sure. I think one of the initiatives that we've really been focusing on is enterprise platforms for this type of capability. So from a technology perspective, how do we bring all of the data scientists, practitioners from across the agency together to help inform and build requirements for an enterprise data science type profile platform, both for analytic capabilities as well as machine learning capabilities, as well as RPA capabilities, right? These types of platforms can be constructed and be used by varying degrees of sophistication. So we're really focused on that, and then developing a pipeline for our data scientists, practitioners, people using this, so that if they discover new tools, new technologies, new capabilities, they have a mechanism to come to the technology team and say, have you thought about this tool? Have you thought about this technology? We want to be an enabler, and that's kind of what we're focused on.
And Oki, I know there's accelerate.
Yes. Yes. So I'm not going to go into much accelerate, leverage blockchain technology. It was the first blockchain network to be authorized to operate in the federal government. But my next vision or next goal is to really automate the CDM program. Automating using blockchain to collect the logs. And the reason why is because a lot of when we want to do forensic investigation or root cause analysis, the logs are not there completely. We do a good work around the perimeter logs, but when you want to do forensic investigation, you have to go down deep into the OS logs, the application log, the database logs, virtualization log if you're in the cloud. What if the logs are there in an ecosystem where you don't have to do data call? When Homeland Security sent out a threat advisory and said, hey, is there this type of zero trust threat patterns or any trace of this? You don't have to do 2 weeks data call. You don't have to go ask Amazon or Azure, give me this log, trying to dig down and do data call. You could have the log readily available. You could run AI against it in a matter of seconds. You could say, hey, Homeland Security, we're clear of this zero trust, 0-day virus. And once you have that log, you could be more proactive about cybersecurity. You could start doing threat hunting, or threat reconnaissance. You could start profiling threats. You could whitelist the normal user behaviors or system behavior and looking at anomalies, almost like how FBI profiles, criminals. You could start profiling, threat patterns. Why they're hitting us, in 2 o'clock in the morning? Why they're hitting us during the holidays? Why they're hitting us during the Super Bowl? So that's half of the CDM program, but the other half is the compliance, the ATO. I think we have a lot of innovation, and then we hit the ATO, and it's like 6-9 months later, you lose all the momentum. I think I could condense that into 2 weeks. Instead of a 6-month process, you can condense it in 2 weeks, basically mimicking the TurboTax model. Think about it. We do a lot of pushing paper around in the ATO package. The controls, the informations are really just cutting and paste. But if you think about the TurboTax model, the evolution of filing taxes, right? Early 50s, 60s, I always say this. You file taxes, it takes you 2 weeks because it's held paper. You're collecting information from different places. Early 2000, you do it online. It still take a couple of days. TurboTax, you can do it in an hour because data is being pulled from different data sets, aggregated, running RPA. In a matter of seconds, you could do it and then give you a confidence score. We could mimic that with the compliance ATO process. We have over 500 controls on the ATO process. AI could run through histories of system security plans, old packages, and guidelines of NIST. You could have confidence score for each control. If it's 85% or above, you could just, the auditor could just look at it and say, let me go check real quick, good to go. If it's under 50%, then I'll dig down deeper, That could drastically condense the process down to 2 weeks and get away from paper. And we could manage risk in real time in that space instead of, you're managing risk right now, not only you're doing check boxes, but you're waiting for 3 years to get re-ATO, you wait a year for a year-end assessment. Things have changed, things shifts daily. You have DevSecOps, you have Agile, your system security postures are changing daily, not every 3 years, not every year. So you could turn a system off in a matter of a minute when you know the security posture has dipped instead of waiting 3 years. And I think that's the key. I think that will change the landscape of cybersecurity for the whole federal government, not just HSS.
And David, perhaps you could go into the AI tech sprint that VA is involved in, how that's improving collaborations for this technology.
Yeah, absolutely. So these sprints that we're holding are going to also incorporate our VA data commons. So this is a safe environment where our collaborators come in and have safe access to our data that we can work with, where there are specific tools. So for example, genomic sequencing tools within that environment. This is kind of the platform of how we're coordinating with people. And so these AI tech sprints with the specific use cases that we're selecting really are an exciting way for collaboration to accelerate. And there are basically these tracks, because when you have the tech sprint, right? There's no kind of commitment, right? But it's a opportunity for a relationship to be built where you work with your academic or industry partner and they come to understand your problem in a better way because you're closely working side by side. You're working with the data, you're working on the issue, you're getting feedback, iteratively developing, and then you're working on issues such as like the data use agreements or how you can actually handle or bring them on. And so what ends up happening is that you have basically an array of digital tools that get developed out that are AI driven, and you have a better selection that then ends up with kind of 3 tracks, right? So you come to the end of the sprint and you can have GIFs. This is one track. So you get to some industry partners understand the problem for the VA, and they say, the VA, now that we know you better and what you actually need, it's very easy for us to just give you X. So here. And that's helpful for us, right? So yeah, that's exactly what we need. That'll help us, right? Another track is CRADA, right? So we're going into a research project. And then there is like a pilot project, right? Where there can be support for that to develop it further. And the idea is that you come to that track, you kind of know how better to assist and address a problem, and that the solutions are much more refined. So it's not this kind of guessing game with a long time period. You work iteratively and quickly to understand, like, yeah, this isn't going to work, or oh yes, this is absolutely going to work, and we want it, and we want to send you on the pathway to kind of bring that solution right to develop the impact, because this is actually one of the key things for the tech sprints and all of the AI work that we're doing. Every AI project that we're working on right now is focused on having an outcome for veterans, right? This is not AI for AI's sake. Our mission, the work that we're doing, is to improve the health and well-being of our veterans. And so when we're developing our use cases, the issues that we're working on, how does this directly impact veterans? That's where we're starting at the end, okay? And then we work back from there and collaborate with everyone to direct them and facilitate the ability to do that. So that's the whole kind of broad picture of what the tech sprint tool mechanism that we're working on. That's what it looks like.
Great. So I know we have just about a minute left, so I want to see really quick, if there's any questions from the audience before I ask my last one. Right up here.
Yeah, is it on? Yeah, okay. Andrew Everson with the Federal Times. It's not on. Oh well. Andrew Everson with the Federal Times. Oki, you mentioned automating the CDM program. Is that different from the neural network that you guys are also working on?
Yes.
Okay.
So Jose's looking using RNN for tick traffic, basically network traffic. I think we need to dig deeper into the actual system, because inside a thread, there might be somebody using a thumb drive or just plugging in the computer or something. Somebody downloaded malware or something. It's not going to get. It's going to get passed through the network. I think you need to go deeper. And AI needs a lot of data. And what has a lot of data? Logs. Because, logs, you're generating digital footprints right now, just sitting down here. Your Fitbit, your laptop, your phone is generating Fitbits. Logs has a lot of data. I think AI could make sense of the data and start being active instead of reactive on cybersecurity.
Any final thoughts?
I have one. As each one of my colleagues here discussed what they're doing within their agency, thought maybe it would be useful to update you on where industry sits, at least in terms of standardization and interoperability of models, right? And so if you start back at NIST and you look at the Cloud Computing Architectural Framework, prior to the release of that architectural framework, no one really knew what we were talking about when we said cloud. Now I sit here today and I can tell you IaaS, I can tell you PaaS, I can tell you SaaS. You understand the model, you understand the consumption, you understand the interoperability of each one of those platforms and frameworks. This recently published an RFI looking for information on what we could do in a similar fashion to develop a framework for AI systems or AI solutions. And so across the industry, we see multiple things that are occurring right now. There's the Open Neural Network Exchange Framework, all right? So that's one that's open source, available so people can exchange models. There's a hierarchical data format, HDF5, which gives customers an ability to create these information stores and then have them interchangeable amongst different models and different vendors. And then I would encourage everyone, if you haven't responded to NIST or haven't started to follow NIST, start to follow that AI framework, because that's going to be pivotal on how we generate better return on investment for any AI projects that you might want to engage in the future.
Great. Well, we are out of time, so thank you so much. These were great perspectives. I was glad to have you guys.
Thank you.
Thank you. Thanks.